All right, today we're going to start talking about how to simplify square roots. You may have done this before in another math class. I know my honor students said they had done some of it in Algebra 1. I don't know if you guys have or not, but we'll just jump right in. So this is necessary for doing what we're about to do, that's geometry. So this is a math skill, sort of like learning your ABCs before you can learn to read and write. This is a similar sort of deal. You got to have this down before you go on to other things. So the definition, a square root of a number is a number that when multiplied by itself gives the original number. That is the definition of a square root. Please underline that or highlight it or do something. A square root of a number is a number that when multiplied times itself gives the original number. So the square roots of 16 are positive 4 and negative 4, because positive 4 times positive 4 is 16, and negative 4 times negative 4 is also 16. Right? So it has two different square roots. Most of the time for this class, we're only interested in what's called the positive square root, or more specifically, the principal square root. The symbol we use for that is this symbol right here. That is a radical sign. So that symbol is the radical symbol. Now, normally in everyday speech, when you think about something that is radical, what do you think about? If something is radical, or someone is a radical.
Like a crazy person.
Like a crazy person, they have ideas that are way different than what most people believe, right? Or if you have a radical new idea, you're like, oh, no one has ever thought about doing it this way. It's completely different. Well, that's kind of where this came from. Once upon a time, no one understood square roots at all, and it was a radical idea. And that's where the name radical, it's the same idea. I don't know which came first. In most cases, the math word comes first, actually. So radical for this term probably predated people using radical as an idea of something that was new and different. Anyway, this symbol, like this, stands for the principal square root, although we usually just say the square root. We usually don't bother saying the principal square root. A lot of things in math, they start dropping words because it's too long. Okay, so they just usually say the square root. Now, before we go on to this next part, I want you to do something for me. Let's draw a square up here. And let's say that the area is 25. And over here, let's draw a slightly smaller square and say that its area is 20. Everybody with me? Okay. Now let me ask you a question. If the area of this square is 25, how long is every side? 5. In this square, how long is every side? Wait. It's not 5. I'm sorry? Okay, sorry. I'm getting too many inputs and I can't sort them all. What?
Square root of 20.
Which is what?
Um,
Yeah, me either. It's the square root of 20, which is about, what would you guess?
like
4.5? All right, who wants to guess higher than 4.5? We'll just make a quick game out of it. Who guesses lower than 4.5? Let's see what it is. The square root of 20 is approximately, 4.5 was a really good guess. It's 4.47 something.
I told you.
So rounded.
Yeah. It's pretty, I mean, that's what I said. 4.5 is a really good guess. Okay? So, these are nicer numbers though, right? 5 is a nicer number than 4.47 infinite number of decimal places, isn't it? In this case, what we call 25 is a perfect square number. And again, that usually gets just shortened to perfect square. Why? Because if that's the area of the square, then the sides of the square are nice whole numbers. What other kind of numbers are perfect square numbers that you can think of? 16, sure. 36 is a perfect square number. 64 is a perfect square number. 144, very good.
121.
121, yes. 9 is a perfect square number, yes.
216.
Pardon?
216.
216? No. 1 is a perfect square number, yep. Okay, there are a whole bunch of them. Now, in most cases, again, we simplify this to just perfect squares. So the explanation for that is right down here. When the principal square root of a number is a whole number, the original number is called a perfect square. Okay, again, it really should be called a perfect square number, but it was too many words, so people just shortened it to perfect square. Okay, here is a list of some perfect squares. You guys listed most of these. 25 didn't get listed, interestingly enough, nor did 81 or 100. But you need to know more than you probably know off the top of your head. You need to know that 13 squared is 169, 14 squared is 196, 15 squared is 225, 16 squared is 256. Okay? I would suggest at the very, very, very least, you get up to 16 squared. Probably would be better if you got all the way up to 20 squared. Okay? How do you memorize those? It's really easy. Make a set of flashcards. Okay? Spend a little bit of time with them. It doesn't really take all that long if you'll do it. If you don't do it, then you won't memorize them. I mean, it's just that simple. And we'll actually spend some time in class on Wednesday going over those. Okay? Because we've got lots of time on Wednesday. All right, so those are perfect squares. Now, we talk about those because we can use these to help us simplify square roots. So, when do we simplify square roots? When we want the square root not the square root. My T looked a lot like an F there. Of a non-perfect square. If it's a perfect square, it's easy. Like if we're taking the square root of 361, that's 19. Now, if you don't have that one memorized, it's difficult. But if you have it memorized, it's really quick. But what if we wanted the square root of 350? And we wanted to simplify that so it wasn't quite such a large number. Well, to do that, we're going to simplify the square root. There are two basic methods: prime factorization and perfect square factorization. Let's look at page 2 and let's look at both ways. So let's say we wanted to simplify the square root of 700. Okay? If you can think of the largest perfect square that will divide evenly into your number, that is always the fastest way to do these problems. Always. Most times students don't, because they can't be bothered to try and think of the biggest perfect square that will divide evenly into it. Some of the sharper students who are better with numbers will, and they'll be done in half the time. Okay? So, for example, here we have the square root of 700. Well, 100 is a perfect square, right? Because the square root of 100 is 10. So I can replace the square root of 700 with the square root of 100 times the square root of 7. And the square root of 100 is 10. So this is 10 square roots of 7. That is the fastest way to do this problem. On the other hand, you can use what's called prime factorization. So when we're using prime factorization, what we're doing is we're going to divide by prime numbers. Now, I guess we should probably talk about prime numbers for a little bit. Prime numbers, anybody remember what they are?
These can only do one multiplied. It can only be more by itself in one.
Okay, that's close. And most people don't get this quite right because it's a little bit I don't know, picky. I don't know if that's the right word or not. Prime numbers are numbers that have exactly two divisors. Themselves and 1. So, some examples of prime numbers. 2 is a prime number. It is the only even prime number, by the way. There's no other even prime number. 3 is a prime number. 5. What's the next larger? 7. Oh, so is it all odd numbers? No, because 9 is not a prime number. It's divisible by itself, 1 and 3. So the next one is 11. What's next? 13. 17. 19. And we'll leave it at that. Notice I didn't include 1. 1 is not a prime number because it has to have two different divisors, itself and 1. 1's only divisor is itself. Okay? Doesn't have two divisors. So, how does prime factorization work? Well, what you do is you select any prime number that'll divide evenly into the number you're trying to simplify. 700 is divisible by 2, so I divided it by 2 and got 350. Then I divided 350 by 2 and got 175. Now, 175 isn't divisible by 2, is it? So I got to pick a new number. Usually once I pick a number, I stick with it until I can't divide by it anymore. So I divided that by 5. 5 goes into 175 35 times. 5 goes into 35 7 times. Now I can't do 5 anymore, so I switch to another prime number, 7. 7 goes into 7 once. Once you get to 1, you have finished the prime factorization. So what I'm doing is I'm rewriting this as the square root of 700 is the square root of 2 times the square root of 2, because there were 2 2's, times the square root of 5 times the square root of 5, because there were 2 5's over here, times the square root of 7. And here's where we get to use the definition. By definition, the square root of 2 times the square root of 2 is 2. The square root of anything times itself is that number. And the square root of 5 times the square root of 5 is 5. So these two are being replaced by 2. And these two are being replaced by 5. And I have a poor square root of 7 that's left without a partner. It gets left underneath the radical sign. So now this is 10 square roots of 7. I think you can see that it takes longer to do it this way, but the majority of my students do it this way because it's very mechanical. They're like, yeah, I can crank these out. All right, so let's do some examples. We will do as many of them as possible both ways. Okay, so if I've got 45, let's try it by perfect square factorization first, because that's going to be faster. Look at your perfect squares. That's on the other page. What perfect square divides evenly into 45? 9. So I'm going to say, oh, this is the square root of 9. How many times does 9 go into 45? 5 times. The square root of 9 is 3. So that's 3 square roots of 5. Now notice it said simplify each completely, and this is going to be on your homework this way also. Give 2 consecutive integers that the radical lies between. And you're like, what the heck does that mean? Well, remember a little while ago we tried to estimate about how big a square root was? How big is the square root of 20? Somewhere between 4 and 5, right? I'm going to do the same thing here. How big is the square root of 45?
Somewhere between 3 and 5.
Pardon?
Somewhere between 3 and 5.
I'd like to narrow it down a little more than that, and it's bigger than that.
7.
Okay, I don't want a decimal. I want, what whole numbers is it between?
7 and 6.
It's
6 and
between 6 and 7, right? How do you know that?
Because 7 is 49 and 49.
Wait a minute, 7 is 49? Be careful what you say. You don't really mean that. What do you mean?
The square root of 7 is 49.
Nope, that's not what you mean either.
I don't know what it means.
7 times 7.
All right, 7 times 7 is 49, or 7 squared is 49. Or you could say the square root of 49 is 7. Got to be careful with what you say. Square and square root, not the same thing. And, go ahead. Yes, Morrissey, I'm still talking to you.
And then the square root of 36 is 6.
Right. We know that the square root of 45 is somewhere between the square root of 36 and the square root of 49. Why did I pick those two numbers? Because they're perfect squares. So it's between 6 and 7. I just want you to have a general sense of about how big a square root is. Now, let's simplify it by doing perfect squares. Or excuse me, we did perfect squares. Let's do it by prime factors. So what's a prime number that you can think of that would divide evenly into 45? Yes, ma'am. 5? Yep. 5 goes into 45 9 times. Can I divide by 5 again? No. I need a different prime number. 3 will divide evenly into 9. It goes in 3 times. Then I can divide by 3 again. Again, once you get to 1, you are finished. So the square root of 45 is the square root of 5 times the square root of 3 times the square root of 3. And what is the square root of 3 times the square root of 3? 3. So that's 3 square roots of 5. So you can simplify it either of those two ways. If you can think of the largest perfect square that divides evenly into the number, it's always faster to do it that way. Sometimes that's hard though. As in our next example. Square root of 147. Most people can't just look at that and go, oh yeah, I know the biggest perfect square that'll divide evenly into that. If you do, don't say anything. Just look smug for a while. Okay? Most people can't think of that. But they probably can think of some prime number that'll divide into 147. What prime number will divide evenly into 147?
7.
7. That's 21. Can I divide by 7 again? Yep. It goes in 3 times. Can I divide by 7 again? Nope. But what can I divide by? 3. So this is equal to the square root of 7 times the square root of 7 times the square root of 3. What's the square root of 7 times the square root of 7? 7. So this is 7 square roots of 3. Now, what two numbers does this lie in between? Well, you may have to look at your perfect squares, but there's a perfect square that's really close to 147. 144. That's just a little bit less than this, and the square root of 144 is 12. So this is between 12 and 13. Somewhere in between those two. By the way, if you're going, well, how could I have done this by perfect square factorization? Well, you would have had to have looked at that and said, you know what? That's the square root of 49 times the square root of 3. Most students don't see that immediately. Again, if you do, count your blessings, do it that way. It's way faster. Okay? All right. Let's go on. Square root of 180. Okay. Which way do you guys want to do it first? All right. So what's the biggest perfect square that'll divide evenly into 180?
I'd say
9.
There's a bigger one than 9.
90.
18's not a perfect square.
90.
90's not a perfect square. Don't just guess numbers that'll divide into it evenly. It needs to be a perfect square that divides into it evenly.
36.
36. How many times does 36 go into 180?
5 times.
5 times. And the square root of 36 is
6.
6. So that's 6 square roots of 5. I will say very few students think of that, and that's okay. Let's find what this is in between. Is there a perfect square that's close to 180?
196.
196.
Yeah, 196 is a little bit less than that, and 169 is a little bit more than that, or excuse me, a little bit less than that. 196 is a little bit more than this. So this is between 13 and 14. Because this 13 is the square root of 169, and 14 is the square root of 196. The square root of 180 is in between those two. All right, well, what if you didn't think of 36 going into it 5 times to start with? Well, let's do it by prime factors. What's a prime number that'll divide into this evenly?
3.
All right, we can start with 3. It doesn't matter. 2 would be fine. 3 would be fine. Whatever you think of first. 3 goes into this 60 times. I do advise that once you pick a prime number, you stick with it until you can't do it anymore. Will 3 divide evenly into 60?
Yeah.
Yep. That goes 20 times. Can I divide by 3 any longer?
No.
Nope, so I need a different prime number.
5.
5, okay. 5 goes into 24 times. Can I divide by 5 again?
No.
So I'm going to switch to
2.
2. 2 goes into that twice. And then again. So I've got the square root of 3 times the square root of 3 times the square root of 5 times the square root of 2 times the square root of 2. What's the square root of 3 times the square root of 3? 3. What's the square root of 2 times the square root of 2? 2. And I've got this square root of 5 that's all by itself. It stays underneath the square root sign. And that's 6 square roots of 5. Any questions about simplifying that one? Because I'm going to show you one other thing on this problem, but I want to make sure everybody's good on this part first.
So if you do it the way of prime factorization, you have to put what is in between.
Yes, that's part of the instructions no matter what. All right, so when I asked what was the biggest perfect square that you could see that went into it, some of you said 9. Okay, what if you had done that? Would it work out? The answer is yes, but there's a little extra work you have to do. Let me show you. If you don't want to write this down, take a quick break from writing, but not from paying attention. How many times does 9 go into 180? 20 times. What's the square root of 9? 3. This is 3 square roots of 20. Here's the problem. That's still not fully simplified. Because what perfect square will divide evenly into 20? 4. What's the square root of 4? 2. So you are welcome to do it that way also. But just be careful, don't stop too soon. Or you've only partially simplified it, and you'll only get partial credit. Okay? I know some students who do this all the time, because if they happen to get the largest perfect square to start with, they're done. So sometimes it's a lot faster. Sometimes, this took about the same amount of time that this did. All right, so let's try this one, 216. Which way you want to try it first? Anyone have a preference?
Do the prime factorization.
Let's do prime factorization. Okay. So what's a prime number that'll divide evenly into 216? 2, okay. It's an even number, so it's obviously divisible by 2. That's 108. 2 into 108?
54.
54. 2 goes into 54, that's going to go twice with 1 left over. 2 into 14 is 7. Can't divide by 2 anymore. I can divide by 3. By the way, do you guys know the trick for divisibility by 3?
No.
I feel like I've heard
Yes.
of it.
If the digits add up to a number that's divisible by 3.
Yes, very good. So
What?
2 plus 7.
if you add the numbers together, 2 plus 7, what do you get? 9. Is 9 divisible by 3?
Yes.
Then so is this. And it works for big numbers too, like 216. 2 plus 1 is 3, plus 6 is 9. Is 9 divisible by 3? Then so is this. It's a neat trick for knowing for divisibility by 3. You know the one for 2, you know the one for 5, now you know the one for 3. So 3 goes into this 9 times. 3 goes into 9 3 times. Don't stop until you get to 1, and 3 goes into 3 once. So the square root of 216 is the square root of 2 times the square root of 2 times the square root of 2 times the square root of 3 times the square root of 3 times the square root of 3. And what's the square root of 2 times the square root of 2? 2. And the square root of 3 times the square root of 3? 3. And this time I have a square root of 2 left over and a square root of 3 left over. So 2 times 3 is 6. The square root of 2 times the square root of 3 is not 6, but the square root of 6. So this simplifies to 6 square roots of 6. By the way, most people don't look at that and go, oh yeah, that's 36 times 6. 216 is 36 times 6. Very few people will look at that and go, oh yeah, I knew that. All right, let's look at what this is in between. What's a perfect square that is near 216? 21?
I mean, 225. That was a mistake.
225?
Which is 15.
225 would be 15 squared. What's 14 squared? 196. Is 216 in between those two numbers?
Yes.
Yeah, so it's between 14 and 15. Okay, any questions about that? All right, we are going to stop there. And I'm going to go ahead and give you your assignment for you to start on.